awk or AWK is a command line tool which is available on almost all Unix-based systems and on Linux and also on Mac. With it, you can process text. We could ask ourselves, why should we use awk and not standard programming languages like Python? The thing is this, that with the command line, you can achieve very high efficiency by typing small commands. So you could use a programming language, but if you try to achieve the same concise and small tasks of processing a file, finding some keywords from these files, and doing a little bit more of a complex operations, you would find that awk can suit you very well. So if you ask yourself, should I study at all awk? Maybe I should just go with Python. So the question should be different. Do you want to do text processing or some minimal text processing or log analysis with the command line? If you find that you do want to do this with the command line, you had better do learn awk and not be satisfied with standard programming procedural languages, because in these languages like Python, Ruby, and even Perl, you find that you cannot describe what you want to do in such a concise way as awk would let you do this. If you just want to parse some log files, dump some files, yes, you could do this with Python, but it's much more concise with awk. I would highly recommend you to study it, because once you control the basics of it, and it's enough to control basics of it, you can do really smart things with short command lines. And when you are at the command lines, and I'm a big proponent of doing many small text processing tasks at the command line, then you should use the right tools. One of the right tools is awk for these kind of text processings. Let's begin discussing how you should approach awk. When you study how to use awk, it's important that you know that awk is structured simply as a sequence of patterns and actions. Patterns and actions. So you type a pattern. For example, I want to match a specific pattern in any line, and then the set of actions. If you have seen awk before, of course, I wouldn't be able to teach you the whole syntax of awk, but I could teach you the concepts at least. So when you go to study the syntax of awk, then you would immediately be able to identify the different parts of awk, and it would be much more simpler to study it. So when you think of awk, don't think of a procedural programming language such as Python, where you have a set of commands, you define what is your data, you read the file, you put it inside a variable, you scan the lines. No. Think in this case differently, which means think of patterns you want to identify in this file. So we can identify patterns such as regular expressions. Okay, let's say pattern identified. Now we specify what is the action to do on this pattern. So we first specify a pattern, and then we specify the actions. And the actions are inside curly braces, and that's it. Okay, so think of patterns, and when the pattern matches, you apply a set of actions. If the pattern does not apply to the current line, then it skips to the next pattern. And if no pattern applies, then it skips to the next line. As for data types, because we can refer to awk as a standard programming language, the data types that awk has are basically only two. It's strings and numbers. And awk would convert from one to another without actually telling you anything. You also have a very minimal support of arrays, like you can access array simply with a variable and then square brackets and then set a value into it. All variables are global. It's very minimal and very concise. So whenever you define a variable, the variable is global and you can access it from anywhere in the short minimal awk program. In awk regular expressions, you define them with a // So if you want to pattern match for error in your log, you do slash error and another slash. This was the pattern. And then you specify what are the actions that you want to do with the curly braces. So we say slash, regular expression slash, and then within curly braces, the pattern that, the actions that we want to apply. As we said, we have two sections to awk, the patterns, the conditions, and then the actions. In the conditions, we can do standard and, or, and not just as you use in Java, usually the ampersand and the pipes. So you can test for a regular expression like slash error slash, which would find if the word error appears in the line, and you can do or debug equals true. Okay, so you are testing both for a regular expression and also for a variable. This can be very useful because once you traverse the lines line by line, and then you know that if I saw an error, then I am expecting the next line to be similar to something. Then when you find the error, okay, in the pattern matching, then what you can do is set a variable in the actions. And now the behavior of your awk program would change. So the basic structure that we have seen so far is that we have patterns. If the patterns applies, then we apply the action that we have specified near the pattern. And then as part of the actions, we can also set variables. And then the next time we apply actions, when we identify patterns, we can test the variables. And also, when we test for patterns, we can also test, are we currently in a state of debug? Okay? So it's very simple. You have a set of variables, you have patterns, you test for the patterns and for the variables, and you apply actions. And it looks simply as on the left side, you put the pattern, and on the right side, you can use new lines, but in general, on the right side, if it's a single liner, you just place the action in curly braces. In addition to variables, patterns, and actions, we also have fields. If inside the action or also inside the pattern, you refer to $1, this means field number 1. $0 means the whole line. So whenever you refer to $0, you refer to the whole line that you are currently processing. And if you refer to $3, then it's field number 3. So you can do stuff like print $0 inside the action, inside the curly braces, which would print the whole line. You could also say print $2, which would print only field number 2. You can also assign a variable to one of the fields. So you can do my var equals $2, which would put the second field inside my var. You can also have blocks. For example, you can do if. You can use the keyword if and then test some variable and then do the actions, and else if some other variable or some pattern, and then do some actions. So basically, up to now, we have almost all the capabilities and all the concept. We can just take a log file. We can apply a pattern. We can check if pattern holds. If the pattern holds, then we specify what are the actions that we want to apply, and we need not just specify the actions. We can also test for variables. You can also define functions, but I'll let you read the documentation for that. There are specific cases. For example, before you examine the line, you probably saw at some point or another, you saw the begin keyword in awk. The begin means do all this before you scan the line. Okay? Before you scan the line, do all this. So what can we specify before we scan the line? We can specify what is the field separator. So we can do begin, curly braces, fs, field separator is comma. And we have just stated that before we scan the line, our field separator is comma, and it's not space, which is the default. We could also specify, so what are the special variables that we can refer to? We have just said that fs is field separator. We can define what is the field separator. rs is the record separator. Record is lines. So we can say that the record separator is \n. OFS is the output field separator, which is just like the field separator, but this is when we are going to print the item to the output. This would be the output field separator. ORS is the output record separator. So we just had FS field separator, RS record separator, OFS output field separator, and ORS, which is the output record separator. And remember that in the context of AWK, then the records are lines. We also have a bunch of variables which cannot be modified by the user. While you can modify the FS, the RS, the OFS, the ORS, you cannot change the NF, which is the number of fields in the current line, because it is a constant. There is a specific amount of fields in the current line. But you can refer, and you can print it, and you can use it, and you can test it. NF, so, is the number of fields in the current line, and R is the number of records that you have seen so far. argv and argc are the skipped arguments. And that's it. That's the core of the awk or the AWK command line processing, and within it, what you can do is this. You can first do a begin block where you define basic variables before you start scanning the file. You can define a few variables like the defaults, some other, and maybe also some message that you want to print in the beginning of your awk program. And then what you're going to do is that awk will scan line by line for you for the field that you have provided, for the file that you have provided awk with. And now you just test. You test your current variables, you test for regular expressions, and within curly braces, you put the actions. That's it. It's very simple, very straightforward. Just think what would happen if you needed to do this with Java, with Ruby, or with Python. You would need to explicitly mention that you scan the line. You would need to read the line. You would need to split the line, but all of this is done for you. You just mention here in awk the variables. You test the variables. You set the global variables, and you specify the actions. And the actions can be setting a variable to a specific value. For example, I'm testing if the word error is in the line. So I do /error/, and then with curly braces, I can set a variable in error is equal to 1. Okay, so I could simply, in this case, count the number of errors. And then what I could do is continue and then test another variable. So the way to structure our program is that once I scan the file, I do some tests and conditions to regular expression, and then I do some actions with curly braces, and then I test again the variables if I have set the variables to a new value, and then I print them. And this is basically all awk. So to recap, awk is a very miniature programming language. It's a command line tool. And if you are trying to process text files in the command line, then you need something very minimal, because procedural programming language would mean that you would simply need to write a little bit more. And in the command line, you don't have enough space. You want to just say, search for this pattern and apply this action. Or if you write a very small program, you don't want a complexity. It's not going to be a program that you write tests for. You're not going to have continuous integration for it. It's just something ad hoc that you run from the command line. And then we said that in awk, the main two structures are the pattern. Basically, every awk program, if it's a single one-liner, you specify the pattern and then the action. You specify the pattern, whether it's a regular expression or whether you are testing for variables, and then within curly braces, you specify the action. In the curly braces, you can do print $0, which would print the whole line, or print $1. And you can also set, you can say in the action, my var equals 1. And then what you can do is that you can test for regular expressions, you can specify the actions, and of course, in the patterns and in the regular expressions, you can do like Boolean logic. You can do if this pattern apply and ampersand, this pattern apply. Okay, or if this pattern apply and this my var is equal to 1, then I want you to take these actions. In awk, you have the fields, which is $0 is the whole line, $1 is the first section, $2 is the second field, $3 is the third field. By default, it's separating it with the space. You can also define functions, and you have a few built-in variables. The fs variable, which is the field separator, is by default space, and you can just change it to a comma. How do you change it to a comma? You say, before you begin to process, the begin, if you see the word begin in awk, it doesn't mean like I begin a block. It means before you do the processing. So before I do the processing, I want you to know that fs is equal to comma. So the field separator is comma, and the record separator is \n. And the output field separator is space. So you do begin, curly braces, fs, comma, rs equals \n, and so forth. And also you have a few fields that you can change. The nf is the number of fields in the current record, the current line. The nr is the number of records or number of lines that you have seen so far. And this is it. I think we got what awk is. It's a little bit difficult to get it from the documentation or from examples because you see it a little bit cryptic. I think I have described to you when you should use awk, if you want to do a very basic command line that scans a text file or a log file. If you use a one-liner in Python, it would simply be more complex. You can do this, but it would be more complex. In awk, it's already built in to scan the lines for you. It's already built in to separate the lines for you. It's already built in to have global variables. It's already built in to identify patterns and then take actions. So what is left for you, the developer, is that to say for this pattern, apply this action. For this pattern, apply this action. And that's the beauty of awk. That's its power. And you should use it when you want a simple, very simple script or a one-liner. It's the perfect thing for you to use for text processing. So I think this was pretty interesting, and I will see you next time.